All right, so we're on 2.4, inequalities with the quadratic. The main part of 2.4 comes from 2.3. So if you understood 2.3, that's the hardest part of 2.4. Does that make sense? And so what I'm trying to do is break our sections within the unit down to smaller bites. So hopefully you see that and you're like, oh, okay. And everything is building on top of each other instead of like, yeah, maybe I'll hear not two works. So like I said, anyways, our objective here is to solve inequalities involving a quadratic function. So the first thing we're going to do is on top of your graph, well, above your graph, please write x squared plus 5x plus 4 is greater than 0. That is the inequality that we're working with. So you're doing x squared plus 5x plus 4 is greater than 0. Everyone's written that down? So in 2.3, we talked about being able to graph. So the first thing we're going to do is just graph the function x squared plus 5x plus 4. Okay. In 2.3, we talked about in order to graph, you need your intercepts and your vertex. Does that sound familiar? Yes. 2.3, intercepts and vertex. Okay. So we're going to find our intercepts and vertex. So the first one, the easiest thing to find is your y-intercept. And that is 4, like Tyler said. Our y-intercept is 4. Okay. Do we understand why our y-intercept is 4? Can we write that right now? No, you just leave where it says y-intercept blank. Oh. Okay. Questions about finding the y-intercept from the function. Okay. The next thing we're going to find is our x-intercepts. And we're going to find our x-intercepts by factoring. Okay. The reason why we can factor this is because are there two numbers that will multiply to give me 4, but add to give me 5? Oh, what? You don't say. So we're going to factor. And when we factor, we get x plus 4 and x plus 1. Because 4 plus 1 is 5, and 4 times 1 is 4, so both are satisfied. If those are my factors, then what are my x-intercepts? Perfect. The opposite. -4 and -1. Okay? Are y'all still with me? Okay. The last thing we need to find is our vertex. And finding our vertex involves using -b divided by 2a. Ringing a bell? Okay. What is our b? What is our a? So we're going to plug that in. And therefore, the x value of our vertex is going to be -2.5, -5/2, right? At this point, you have the choice to either substitute this value back into the function and solve for the y, or is there a formula that you could use instead? There is. The formula is 4ac minus b squared divided by 4a, right? If we're not good at working with fractions. I'm okay with working with fractions, so I'm just going to go ahead and substitute it in. Okay, I'm going to go ahead and substitute in, and I'm going to work with my 25/4 and my -25/2 plus 4, and I'm going to simplify it down to 9/4. If I'm not comfortable with working with fractions, remember, you can always use to find your y value, your h, your k, I mean, not your h. I could have turned that into a k. You would do 4ac minus b squared divided by 4a. And guess what you're still going to get? You're still going to get -9/4. Okay. And again, do that if you're not comfortable with fractions, because then the fractions will all work themselves out for you. Okay. All right. Do I have everything I need to graph? Yeah. 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 I have my intercepts and my vertex. So now we're going to graph. So on your paper, you can create a graph. I did my more to the left because I had more negative x values than positive x values. So create your graph however you want to on your little sketchy sketch. And that is all 2.3. So if you struggled here, then you need to make sure you come to tutorials today or during your lunch tomorrow to get help with 2.3. Because that's what this is from. All right. Now we're going to do the 2.4 part of it. You just had to draw some lines and some dots.
That's great. Yeah. You've been Daniel, so. Oh, man.
All right. So now we're gonna do the algebra, the 2.4 part of it. And 2.4 is saying, where is this function greater than 0? Okay. The reason why we know it's saying that is it says right here, x squared plus 5x plus 4 is greater than 0. Okay. When something is greater than 0 on a graph, that means it's above the x-axis. That's what it's asking us. When is this function above the x-axis? So I'm going to take my highlighter and highlight when the function is above the x-axis. So I'm above the x-axis here, and I'm above the x-axis here. Does that make sense? So graphically, that's my solution. I just highlight it when it's greater than 0. Huh? No, you're going to write it as an inequality in an interval. I don't know what you just said. No, you would draw and highlight if you would do a graph. Because it is not the function. Okay. So as an inequality, this is saying x, when x is to the left of -1, so when x is less than -4, do we see that? And when x is to the right of, I said -1. X is to the right of -1. So when x is greater than -1. So my inequality solution would be here. This would be the solution as an inequality. Does that make sense? Because that's the points that that's the size that I have highlighted. Yes? Okay. To write it as an interval, you would write it as this. So from -infinity to -4 or -1 to infinity is how we would write it as an interval. So this is inequality notation here, and this is interval notation here. Is that doable? Okay, and just for safe measures, there's one last way that you can represent it, but we won't be using it. But maybe if you take college algebra or something else, your professor may use it, and it's on a number line. So on the number line, you're just literally taking the x-axis values, and you are using parentheses and or open and closed circles to represent which direction it's going. So taking it back to 8th grade of the number line with the open and closed circles and being either connected or not connected. Okay. All right. Questions, comments, or concerns? How we feel? Okay. So the 2.4 part is in the red and highlighted. Everything else was what? 2.3. Okay. All right. So let's do another one. So this time you're going to write down x squared is less than or equal to x plus 6. Okay. So you're writing down x squared is less than or equal to x plus 6. We're going to do this problem twice. We're going to do it in example 2 and in example 3. In example 2, we're going to do method 1. In example 3, we're going to do method number 2. Got it? So we're going to start with method number 1. So for method number 1, we want to rearrange the inequality so that 0 is on the right side. So what would I need to do to get 0 on the right side? Exactly. We're going to minus, subtract x and 6, right? So when I do that, I'm left with this. So now we're working with x squared minus x minus 6 is less than or equal to 0. What are your questions about getting the right side to 0? Doable? Okay. Now we're just going to go through the same steps. We're going to find our intercepts and our vertex. Okay. What is our y-intercept? -6. What would our x-intercepts factors be? What multiplies to give me -6, but adds to give me -1? What two numbers? There we go. So we're looking at -3 and +2. Okay, so this factors out to be x minus 3 times x plus 2. Okay, what are our x-intercepts then? -2 and +3. Easy enough. The next thing we need is our vertex, right? Our vertex, remember, -b divided by 2a. Our b is -1 and our a is +1. So when we plug those values in, we get 1/2. Again, if I'm not comfortable with fractions at this point, to find my y value, my k, I could do 4ac minus b squared divided by 4a. Or I could just take the value and plug it in. I would go through and simplify that, and it comes out to be -25/4. Okay, so therefore my vertex is at 1/2, comma, -25/4. So -6 1/4, right? Do I have everything I need to graph? Yes, I do. So I'm going to create my graph. So I put in all my intercepts, and I made sure I drew the graph through my intercepts and my vertex. So this time we're looking for what? The portion below, because it says less than or equal to. So we're now looking for when is it below the x-axis. So when is our graph below the x-axis? So from -2 to +3 is when I'm below the x-axis. Does that make sense? Okay, so we're going to write it as an inequality, and then we're going to write it in the interval notation. So as an inequality, that means that I in between, right? So x is between less than +3, but greater than -2. And notice that this time I put equal signs. Why did I put equal signs? Because it's less than or equal to. So it also can be equal to 0. So this is my inequality. What would my interval look like? What are my behaviors, my end behaviors on it? Well, huh? They're closed. So how do I represent that it's closed in interval notation? I use brackets. So as an interval, it would be bracket -2, 3. And that's because it's equal to, right? All right, we're going to take it back to middle school really quick and just look at it as a number line. So as a number line, my solution would be between -2 and 3. And it would be closed circles because it says equal to. I use brackets, so my circles are now closed. Do we remember number lines from 8th grade? Yes. I hope so.
That was my favorite.
I'd be a little concerned if we didn't. All right, how do we feel about method number 1? Okay. All right, method number 2 is a little different. So method number 2, so example 3. Method number 2 is you're going to graph each half separately. So we're going to graph x squared, and we're going to graph x plus 6. Okay, so we're going to graph x squared, and we're going to graph x plus 6. This is our parent function, right? And because it's our parent function for quadratic, it starts at the origin, right? And then everything is just squared from that. Do you remember that? So when we graph it, we're going to end up with something like this.
Well, when you say method 1, method 2, you can use
Either or to solve that type of problem. Okay, so method number 2 is we're now graphing both sides. So we graph the quadratic and we graphed our linear. Our linear goes through 6 because that's its y-intercept, and it has a slope of 1. and you would graph it so that you can know where it would intercept your quadratic at. So in this case, our intersection takes place at -2, 4 and at 3, 8. I think. Can't remember. Yeah. You want to identify the points of intersection. Or it's 9. It's 9. It's not an 8. Duh, Shauna. It's 3, 9. Childish, Tyler. Childish. All right, here we go. So now you're looking for, when they're equal. So the intersections represent that they are equal. Does that make sense? Yeah. So your intersections represent that they're equal. And that means 3 or -2. The next thing you're looking for, when is x squared less than x plus 6? So when is x squared beneath x plus 6? Well, let's highlight it. So the blue is below the green from here to here. Does that make sense? And so therefore, our solution is still where? It's still between -2 and +3. Okay, so that's how that would look. So if you chose to not give one side equal to 0, that means you're going to graph not just one function, but 2 functions, find their intersection, and then determine, based on what it's saying, when is the graph either above or below. I personally am a fan of method 1. I'd rather just go ahead and make one side 0 and then only graph one function. But if you're more comfortable with method number 2, I just wanted to expose it to you and for you to choose your own path. Make sense? All right, questions, comments, concerns about method number 2. Okay, again, back to middle school, it would still be the same number line and it would be brackets. So therefore it would be closed circles from -2 to 3, +3. All right, I'm going to pause and I would like for you to attempt this one. Okay, it is going to be a little bit more for you to find your x-intercepts, but I believe you can do it. Your hint for finding your x-intercepts is going to be the quadratic formula. It's not going to factor pretty. So you're going to do the quadratic formula.
Oh.
Yay. She's so sweet. And I left you room at the bottom. You should have room at the bottom of your notes so you'll do the quadratic formula. If you need help remembering the quadratic formula, sing it with me. X equals -b plus or minus the square root of b squared minus 4ac divided by 2a. Hey, okay. I don't. Let's check. All right, so when you're graphing this, you would find your vertex, and you would have gotten that your vertex is 2, -1. The reason why I'm jumping straight to the vertex is if you did the quadratic, what did you learn about your zeros? They're imaginary. Does that make sense? So the only things you can graph are your vertex and your intercept and use that as your information. So notice how I graph my vertex and my intercept. And I'm going to use my axis of symmetry to reflect my intercept. So if I'm at 0, -9, my vertex is at 2, -1, then by symmetry, my other point's at 4, -9. And now I'm going to connect those points. That's because the quadratic formula told me that my x-intercepts were imaginary. Does that make sense?
Yeah.
All right. So now it's saying, when is it less than 0? When is this function less than 0?
All the time.
All the time. So what does that mean?
Infinite.
Infinite, all real solutions. So this is an example of all real solutions. Okay. And it should say it on your paper also.
Can you use the weird R for that or different?
You can use the weird R. Okay, if you use the weird R, it would look like this. So you would write X is all real. All right, no, your assignment is coming tomorrow.
Yay!
All right, any questions about 2.4, or do we see that it's not terrible? Okay, the hardest part of 2.4 is making sure you could do 2.3. And that concludes it.